So today in our notes, we're going to start factoring. So we're going to undo multiplication, so we're working backwards. When you think of factors of 6, I'll pick a small number so there's not as many. What are the factors of 6? 3, 2, 1, and 6. The number is always a factor of itself, right? And 1's a factor of everything. So on your agendas, you have a multiplication table. If you're struggling with your factors, you can go to that table, but you really should find an app on your phone or go on the web and really go back and try to review so you know your factors pretty quickly, okay, numerically, because we're going to do it algebraically, which makes it tough. Now, what's the GCF, greatest common factor, for 12 and 18? 6, yes. What's the greatest common factor for 50 and 100?
20.
No. No, not 25, even larger than 25, 50. So one method you could do is check to see if the smaller number goes into the larger number. If it does, then it's the greatest common factor. If the smaller number doesn't go into the larger number, then you have to either write out the factors and look, okay, or you may know it automatically. At the top of the page, it describes what a factor in GCF is. So factors are numbers or variables, because variables represent numbers, that can be multiplied together to obtain a product. So I want to write factor times factor equals product. If it's a GCF, a greatest common factor, then it divides evenly into each term. So if it's a trinomial, the GCF of the trinomial is a number or a variable that goes into all the terms of the trinomial. Okay? And then for any variable that all terms have in common, we use the lowest exponent. So first, I want to talk about, so I want to go to a separate slide. And if you want to put this on your index card, you can. I want to talk about the factors algebraically. So let's look at the factors of x, x squared, x cubed, x to the 4th, and x to the 5th. Is x a factor of x? Yes. It's always a factor of itself. So the factors, so x is a factor of x. Is x a factor of x squared? Yeah, because x times x is x squared. Is it a factor of x cubed? Is it a factor of all? Yes. Now, moving to a larger exponent, is x squared a factor of x? No. Because you can't multiply x squared times anything that's never going to give you a smaller exponent. Because what always happens to the exponent when you multiply? It gets bigger. Is x squared a factor of x squared? Is it a factor of all these below? Well, here, what is x squared times x? X cubed. So it's a factor of that. Can you multiply x squared times anything to get x to the 4th? Times x squared. And then x squared times what gives you x to the 5th? So it is a factor. Starting with x to the, so x cubed. Is x cubed a factor here? No, because it's too large, right? There's too many. So it's going to be a factor of itself. Is it a factor of x to the 4th? X to the 5th? Do you see the pattern? Adding another, so x to the 4th would be a factor of itself and anything that's larger. And then last, x to the 5th would be here. So over on the side, what is the GCF of x to the 3rd and x to the 5th? What's the GCF of x to the 3rd and x to the 5th? This row and this row. X cubed. Yeah, good. Thank you for those raising your hand. So x cubed is the greatest common factor. It will always be the term with the lowest exponent. So 3 is smaller than 5. So that's going to be x cubed, the greatest common factor. Okay? So back to the note page. I just want to explain why, went too far, we use the lowest exponent. So take a minute to fill in the table. It's pretty basic. What do we multiply 2 by to get 6? 6x times what is 24x squared? Dan, what's the first row? 2 times what is 6? 3. Next row. Elijah, what do we multiply 6x by to get 24x squared? 4x is good. So therefore, on the right, 24x squared divided by 6x would be 4x. And then what do we multiply y minus 5 by to get y squared minus 5y? Y. Just y. Because y times y is y squared. Y times negative 5 is negative 5y. Therefore, when we divide, we get y minus 5. And the last one's already filled in. Okay? But I want you to recognize always, when you multiply the last two numbers in your binomials, that answer will always be the last number in the trinomial. Negative 7 times negative 8 is a positive 56. This negative 15, how do we get that with these two numbers? How do you get negative 15 from a negative 7 and a negative 8? By adding them. Yeah. So this will always be these two numbers combined. As I mentioned before, over on the side, and I want you to keep using that, when you write it side by side, the little smile is negative 7x. Big smile, negative 8x. When you combine those, that will always give you that middle term. The little smile, big smile. Okay? Because we're going to eventually get to factoring that trinomial. All right, down below, go ahead and answer 1 and 2. What are the GCF of those terms? Chris, what's the GCF of 4x and 4y? Part of that answer is correct. Elijah? 4. They both have a greatest common factor of 4. Okay, 4 goes into 4x, and because this is really 4 times x, and this is 4 times y. So they both have that common factor of 4, or GCF of 4, but they don't have a variable in common. So that C, what's in common to both those terms, is only the 4. So the GCF is 4. What about number 2? Jack? 2x is right. 2x times 1 is 2x, and then 2x times 2x is 4x squared. Good. Moving down, just getting a little bit longer. Number 3, you want to first take a look at the GCF for 10 and 15. 15. So GCF is for 10 and 15, 5. What about for the x squared and x squared? It has to be a common variable. The GCF for x squared is x squared. Do they have any variable in common for the y's? No. So GCF is 5x squared. This shouldn't be written as far apart as it is. Is there a GCF for 2 and 3? No, because 2 and 3 are special numbers. Where's the pair? Do you have yours in? No? Oh, it's your necklace. Sorry. What's the GCF for 2 and 3? Nothing, because they're a certain type of number. It begins with a P. Prime. The only factors are 1 in itself. So there's no GCF for the number part or your coefficient, but do they have a variable in common? No. So the GCF is 1. All right, so now we're going to factor binomials, trinomials, polynomials. So we do the same thing, okay? Rather than having the plus sign, I could get rid of the plus sign and then just put the comma. Okay, so we identify the GCF in the same way. What is the, I'm going to explain the steps with example number 1. Okay, so what's the GCF for 12x and 24y? Step number 1, find the greatest common factor. Does 12 go into 24? So that would be the largest number. Do they have a variable in common? No. So you pull out the GCF out front. So it's GCF, and there really is no dot. It's really just GCF and then a parenthesis. Because isn't it when you write a number out front of a parenthesis, doesn't that indicate multiplication? Yeah, so we really don't need that. Quotient is the answer you get when you do what operation? Divide. So GCF would be 12. You set up one parenthesis when it's GCF factoring, and then the answer that goes in the parenthesis is what you get when you divide by 12. So 12x divided by 12 is 1x plus 24y over 12, 2y. And then you can check. You only have to write out the check if it says to. This is the answer, and you can always check by multiplying. 12 times x, 12x, 12 times 2y, 24y, it checks. Greatest common factor for bx and by? Dave? B. Set up your parenthesis. Now, I really don't need to see any work for these. So you didn't have to show me here the division by 12. You can go right to the answer. So another way to do these rather than divide is to say, well, the number that I put here has to multiply to bx. So it must be x. And then here's your plus sign. Whatever I put here has to multiply to by, so it must be y. So it's b times x plus y. So I'm going to add one. What is CP minus CQ? How does that factor? Okay?
C times P and Q, or minus?
Yes. C times P minus Q. You could get that by dividing by C, or you can ask yourself, what do you multiply? Okay, but that's right. So moving to a trinomial now. What is a factor of each one of those terms? And also the greatest common factor? Sean? X. Yeah. We've got a 1 here, a 7, and a 5. No greatest common factor other than a 1. We don't need to pull out the 1. You can, but they all have an x in common. So x times what gives you x cubed? Okay, let's divide by x. What's x cubed divided by x? X cubed divided by x, Michelle? X squared. Keep the plus sign. 7x squared divided by x? 7, because there's a 1, 7 over 1, x. Minus negative 5 over 1 is negative, 5 divided by 1 is 5. Do we need an x? No. What about for 6p to the 6th, 24p to the 5th, and 18p cubed? Sean? Well, p does go into p to the 6th. It does go into p. Well, let me show you what happens, okay? So divide this by 6p. What goes first? 6p to 6 over 6p would be p to the 5th. You got to subtract 6 minus 1. Plus 4p to the 5 minus the 1, 4, plus 3 p to the 2. If you look here, is there a greatest common factor in that parenthesis? They still have anything in common? Yeah. And that means we didn't factor it correctly. This is not the GCF. So it's got to be 6p to the what power? It's greater than an exponent of 2, because we'll still have 6 minus 2 would give us the 4, right? 5 minus 2, the 3, and then 3 minus 2 would still give us a p. We want no p's inside, so it's got to be p to the what power? The third. So 6p cubed should be our GCF. Therefore, we get p to the, we're going to have all the same numbers as this trinomial, but now 6 minus 3, 3. So plus 4p, 5 minus 3, 2. And then plus 3, p to the third over p to the third is just p to the 0, which is 1. Well, they cancel out. So now that we know that, what's the GCF for 14ab cubed and 42 a squared b to the fourth? 14 is right, Jack, numerically, but what about for the variables? If you look at a and a squared, yep, a is the smallest. What about for b cubed and b4? No? Going back to the front, it was your variable part with the lowest exponent, which would be the 3. So it's going to be b cubed. Divide this by 14ab cubed. Well, what is 14ab cubed divided by 14ab cubed? 1. 42 over 14 is 3. A squared divided by a is going to be a. And then b to the fourth divided by b cubed is b. Last one, it's a trinomial. Before we look at the challenge question, what's the GCF in the last one? Sarah? Yeah. You look at the last term, 3CD, it goes into all. Okay, so that is our GCF. So divide this by 3CD. 6 divided by 3 is 2. C cubed divided by c is c squared. The d's will cancel out. 12 divided by negative 3 is negative 4. C squared divided by c is c. D squared divided by d is d. And then plus, what goes at the end?
1.
A 1. What about this challenge question? It's x times x plus 1 plus 3 times x plus 1. What is the common factor as I read it aloud? Elijah? What's that? It's not 1 because the two factors are, again, this is x times x plus 1. This is 3 times x plus 1. So is the common factor the x and the 3? Or the x plus 1 and the x plus 1? Yeah, so we pull out the x plus 1 and then make your parenthesis for the other part, the quotient. If I divide this by x plus 1, what do you get? Cancel, cancel, you get x. Plus, divide this by x plus 1, and what do you get? 3.